number 4 on how to evaluate integrals, indefinite integrals, using the U substitution method. So let's say we're to evaluate the integral of e to the 3x divided by e to the 3x plus 1 dx using the U substitution method. Alright, so let's get started by refreshing our memory on what the U substitution formula is. So this is the 4th time you're seeing it. We went over it in examples 1, 2, and 3, so you must be a master at it right now. So the formula is as follows: the integral of f of g of x dx, f of g of x times g prime of x dx is equal to the integral of f of u du. Just think about it as the reversal of the chain rule for differentiation. Okay, so the power of the U substitution is that it enables you to rewrite complicated U substitution problems in a format that's very easy to integrate. Okay, so let's go ahead and attack the problem. So we have the integral of e to the 3x over e to the 3x plus 1 dx. Now, one good practice, as we did in problems 1, 2, and 3, is to rewrite it in a way where it's easy to identify what the composite function f of g of x is and what g prime of x is, the derivative of the inner function. So we're going to rewrite this problem as the integral of 1 over e to the 3x plus 1, this is the composite function, times e to the 3x dx, the derivative of the inner. Okay, so let's go ahead and identify what u is. So this inner function right here is u because when you differentiate that, you end up with a multiple of this. Let's show that on the side here. So we say u is e to the 3x plus 1. When you differentiate this, du dx, du dx, du is going to be, now we're going to use a chain rule here because we have a composite function. Derivative of the outer function is e to the x, so e to the x or e to the u. So the derivative of the outer evaluated at the inner is e to the 3x. And then we're going to multiply that by the derivative of the inner function, which is 3. The derivative of 3x is 3. Okay? Plus the derivative of 1 is just 0. This was du dx, so we multiply both sides by dx, so we have that. 3e to the 3x dx is what du is. Now, do we have a perfect match for substituting du? Let's see. If you look at what we have here, we have e to the 3x dx, and over here we have 3e to the 3x dx. Does it match perfectly? Sometimes it does, sometimes it doesn't. In this particular case, we have a mismatch, so we have to fix that problem. Okay, so to fix that problem, we're going to have to divide both sides by 3. So divide by 3. Because this component here doesn't have a 3 in front of the e, it doesn't have a 3 coefficient, so we can't have this right here. Alright, so that divides out, and that gives us du over 3 is equal to e to the 3x dx. This is exactly what we want. We have a perfect match. Check this out. We can now replace this entire component with du over 3. Very important. You want to know exactly what u and du or its multiple is before you carry out your substitution. Alrighty, so now we are going to go ahead and substitute. Let's do our substitution. This integral that we have right here is going to become the integral of 1 over u times du over 3. Let's factor out that du over that 3 on the bottom, so we have 1/3 times the integral of 1 over u du. Isn't this fantastic? Take a look at the original problem we have, and after the U substitution, look at what we have. This is really, really great. Now, what is the integral of 1 over u? We've confronted this particular integral in question number 3, and we talked about using the power rule incorrectly here. In this particular case, do you use the power rule or not? The answer is no, you do not use the power rule. For this particular integral, you're going to use the integration rule. The integral of 1 over u is the natural logarithm of the absolute value of u. Okay? So that's what the integral is. And don't forget the plus c because this is an indefinite integral. Are we done with the problem? We are not done. Remember, after you substitute and integrate, you have to do what? You have to resub. Okay, what you substituted out for u, you have to plug it back in. So we're going to carry out our resubstitution step, which will be the final step here. So the answer we got was 1/3 times the natural logarithm of the absolute value of u plus c. So when we resub, this is going to become 1/3 of the natural logarithm of the absolute value of e to the 3x plus 1 plus c. And there goes your final answer. Okay? Alright, now we have some practice problems for you to try out to demonstrate that you have mastered the art of integration using U substitution. Alright, so let's have you go ahead and try these. Task is as follows: you to evaluate the given integrals. So for question 1, what if you were to evaluate the integral of secant square x over the square root of 1 plus tan x? Number 2, what if you were to evaluate the integral of dx over sine squared 3x dx? Yeah. Alright, number 3, what if you were to evaluate the integral of cosecant square 4t divided by 3 plus cotangent 4t dt? And then lastly, number 4, what if you were to integrate e to the 5x over 2e to the 5x plus 4 dx? Alright, so what I would like you to do, go ahead and pause this video presentation and attack these 4 problems. When you're done, click back on the play button and then you're going to see what the answers are. Alright, so hopefully you had a chance to try out these 4 problems. The answers are as follows. For question number 1, the answer is 2 times 1 plus tan x raised to the 1/2 plus c. Number 2, the answer is negative 1/3 cotangent 3x plus c. For number 3, the answer is 1/4 times the natural logarithm of the absolute value of 3 minus cotangent 4t plus c. And for number 4, the answer is 1/10 times the natural logarithm of the absolute value of 2e to the 5x plus 4 plus c. Okay? So we'd like to know how well you did on these practice problems. Did you get 100%, 75, 50%, 25%, 0%? Let us know in the comment section below. And if you have any questions or any clarifications that you like, go ahead and place it in the comment section. We'll be glad to address those.